Welcome back to the morning show. It's Wise Guy Wednesday, that sneaky time of the week when Matt Sellen joins us and makes learning fun. Now, today we're talking about crystals and snowflakes. And everybody's heard that no two snowflakes are exactly alike, but there are categories, I guess, right?
That's right. They're very similar in many ways, and we'll describe that in a second. Let me just mention, as a follow-on for the last segment, that I'm going to put on the Wise Guy website some recipes for making your own crystals, and especially you can do it with salt and with sugar, and you can get rock candy you can make out of sugar, and you can get great big crystals on a string, and then you can eat them. So it's kind of a good Christmas project. So we'll see if people can do that before next week, and let me know how it works. But snow is very interesting. Snow, or when water molecules get together when they have time to arrange themselves the way they want, they tend to form a hexagonal kind of a structure, sort of like this. And if you look at the first graphic image that I sent you, if we can bring that up, there we go. That's a snowflake, and you'll notice a couple of things about it. It has a hexagonal or six-sided symmetry, and all snowflakes tend to have six sides. And it starts out with a little hexagon in the middle, and then you have these interesting branches that stick out in all directions, and all the branches look pretty much the same.
Right.
But they're not exactly the same, and if you look very carefully, they're not identical, which is kind of reassuring, because that would be pretty spooky if you think about it. But we'll describe why they're so similar in a moment. If you go to the next picture, you'll see what I did here is I was just playing around on the computer, and I started with a little center cell, which is sort of blue, and it's just a six-sided shape. Then I just copied that shape over and over, and I just rearranged them so that they were touching all the sides. And you'll see, as the thing gets bigger, it still has the same six-sided shape. So even if you start with one molecule, but you add many more, even if you get to something large, it still has the same six-sided shape.
Peel away layer by layer a crystal that you found, say, like one of the ones you showed us earlier,
That's
it would
right.
retain that shape down to the atomic level.
Exactly right. So that even though you start at the atomic level with something that has six sides, once it gets big, like a little ice crystal, it still is going to have six sides, which is kind of neat. Now, once it gets big enough, and you have the wind-blowing water molecules around it that are starting to stick to it, you get what's called a branching instability. And if you look at the corners of that little six-sided, in fact, I can show you right here. If you can, I have a little piece of paper I can show you. So imagine you have an ice crystal, which is the shape of this purple thing that I'm holding up here. On these corners, you get, it's like a snow fence, you know, where you have a bump in the land, snow blows over it, and it tends to get stuck there.
Right.
So the molecules tend to stick to these corners, and the shape of the things that form at the corners depends very sensitively on the temperature and the humidity. So if the temperature and humidity is in one sort of configuration, you get these little blobs, and if it's some other set of numbers for temperature and humidity, you get these little spikes. And if you change it even just a tiny little bit, you get something completely different. But the point is, all the corners, everywhere on the snowflake is experiencing the same temperature and humidity. That means that all the sides are going to grow the same.
Now, the one there on the left with the spikes, would that be your cold air, dry snow that doesn't compact as well, or is we talking such a subtle difference?
This is still a very small crystal, so this is, I couldn't tell you that. But this is why all snowflakes are a little bit different, because they all grow up under slightly different conditions, but their sides are all the same, because the snowflake is small enough that locally around where it's forming, everything is the same.
Okay.
And so it's pretty nice that way. And so what I want people to do, in fact, what you should do is go to a website called snowcrystals.com and have a look. There's some beautiful pictures there. And the experiment I want people to try for next week is to make ice cubes using distilled water. You might see something interesting happening. And we'll talk about that next week.
Okay. Matt Sellen, our wise guy, telling us about crystals and snowflakes. Hopefully we won't see any for a while, but looks like maybe some light snow this afternoon. Here's our